Hello friends, welcome to Multiverse, and today in our program we will discuss about what is dark energy, how does it shape our life, how does it shape our universe, and how does this mysterious form of energy affects us. I'll be right back, don't go anywhere, and I will discuss in detail all aspects of dark energy with you. In order to understand the nature of the universe and more so about the dark energy, we need to go back in time and understand the birth of the universe. For unknown reasons to scientists and mankind, we really don't know what really triggered the birth of the universe. And we basically think that the universe was confined to a point which was infinitely small, smaller than the electron, and for some reason it actually burst out into reality. And that is why we have to really understand if dark energy is a component which exists in the nature in our universe. What is the origin behind the dark energy? We need to understand completely, and that is why I'm talking about the birth of the universe. So the birth took place. However, at that point in time, there were no matter, there were no electrons, there were no protons. It was just a burst of energy. And you already know, friends, that in order to produce light and produce sound, you need some sort of matter through which light can travel or through which sound can travel. So, in nutshell, the initial birth of this universe, which took place 13.5 billion years back approximately, happened without any sound or without any bang. It was just an expansion of the energy from a very hot point in space, and suddenly it expanded into a vast universe that we know it today. And in order to produce the light and sound, there were no matter. And then the expansion also happened faster than the speed of light. The initial expansion that happened was faster than the speed of light. So in nutshell, it seems that the birth of the universe violated the laws of the nature, but not really, because birth of the universe was triggering of space-time, which is the space, creation of space and creation of time. Before that, we don't know. Our imagination can take us anywhere, but scientifically, we do not know what existed before this event called Big Bang. So, within less than a second, the uh, universe expanded faster than the speed of light, and it was still very hot. And it was so hot that today we know these fundamental forces that exist in our universe, like electromagnetism, electricity, gravity, um, weak nuclear force, and strong nuclear force. These are the fundamental forces which are present in our universe. They were combined into one particular force, and it's very difficult for us to perform any experiment and to prove this experimentally. However, we assume that at that point in time, uh, because the early universe was so hot, all these forces that we see them as separate forces and separate effects, cause and effect, they were actually having one, they combined into one, and there was one force available. But gradually the universe continued to expand and continued to cool down up to the point of about 300,000 years after the first bang. The temperature became slightly cooler, and that allowed the lumps of matter to be created. And because the temperature was not as hot at like trillions of degrees at that time, so it cooled down a little bit. but still it was still very hot at that point in time. So the lumps of matter started forming, and the nature of the force as we know it today, the four fundamental force, and the fifth one is gravity, they got separated from the primordial energy force field that existed at the time of the Big Bang. So almost 300,000 years after the initial bang, we started seeing the first matter to form, and also different kinds of forces that started coming out of the initial Big Bang remnants. However, the temperature was still very hot, and the initial matter, which was formed in the form of either electrons or neutrinos, they were formed in pair, which means there was a electron and there was an antiparticle, which is called positron, was also created, and this was a cause of the second bang which we experienced at that point in time. The matter and antimatter, when they come close to each other, when they touch each other, they annihilate each other into a big explosion, and the 100% of this matter converts back into energy. So you see, friends, what was going on that time is that the universe was cooling down, the matter started forming, and then there was second bang, because the matter and antimatter which formed at that point in time annihilated each other, and it turned out that the matter was almost like 5% more than the antimatter. So however hard we try, we do not get any evidence of any antimatter, at least in the observable universe that we have around us, and we don't see any evidence of any antimatter existing, although mathematically it should have been created when the matter got created, and today in our labs we can create the antimatter. So but we do not see the antimatter in our nature. So that is the first puzzle that we have not found answer to. Second is, when the remaining 5% matter that remained, it was not a homogeneous distribution of that matter. The matter was scattered, and that was a big thing that happened, because if it was a homogeneous, then the matter wouldn't have come close and created large bodies that we see today. And therefore, when we look back using these smart telescopes, there is a limit to what we can look back in time, because our causality or our understanding of how much we can experience and how much we can experiment depends on how far back in time we can look at. And since there was a time, there was no light, there was no matter, there was no sound, there is no way for us to basically go back in time and experience those things and probably see the early part of the universe. So our view or our experimentation ability to do fact finding or experiment and prove whatever we have found mathematically, prove it by experiment, is limited at that point. So I think the point I'm trying to drive is that initial expansion of the universe, which happened faster than the speed of light, happened without any light, without any sound, without any bang. It was just a rapid expansion. And the second bang happened, and this is something that we can see. And the second bang actually left behind the evidence, which is this picture, as you see, is called the microwave background. And this is a background which is found everywhere in the space. And as you can see that in this picture, I'm trying to show that the different lumps of the matter got accumulated and eventually created large galaxies and large stars, etc. Now the whole activity continued, and the stars formed, very large stars, black holes, planets formed, and things started moving slowly, gradually. The universe was taking shape up to the time of up to 6 billion years after the initial bang. And for unknown reasons, instead of slowing down, it was moving at a rapid speed at that time. But after 6 billion years of the Big Bang, something happened which we cannot explain. The speed of expansion suddenly started picking up. And it's not only picking up after that point, it is actually accelerating. And when it is accelerating, that means the expansion is now every hour is happening more than the previous hour. So that means the speed is increasing as we progress in time, and that is why it was baffling the scientist that what is the reason for this expansion which started suddenly 6 billion years after the birth of this universe. And while exploring all these activities, scientists again found that the speed at which the matter is formed and at which it is rotating inside the galaxy is way faster than it should. Basically, the gravity is not enough of the matter is not enough to hold the galaxy in its position, in its wheel or its shape, and it is rotating. So the scientists then got baffled, and they did further study, and they mathematically found that the matter required to create extra gravity in order to hold the galaxy was 5 times more than the actual matter that we see in the universe. So since scientists did not know what is this matter which does not react with the actual matter that we see, this matter is invisible and it is more abundant as compared to the stars and the galaxies that we see and look around in our space. So this was a very baffling find, and it was also proven mathematically that there is extra matter required, even though for last 50 to 60 years we have been trying to find out this mysterious matter. We have not able to even find single particle of this matter, but we know for sure that this kind of matter exists and that creates gravity. I mean, the gravity has to be created by something, because the extra gravity which is helping formation of galaxies and stars and planets definitely has to be there, and we cannot see that. We do not know what is the property of this matter. We cannot even identify the particle of this particular different mysterious matter. Since we are not able to see, we called it dark matter. And now we know that the dark matter, a matter which exists in the universe, but we cannot interact with this matter, we cannot even see, we cannot measure, we cannot identify any charge in that matter. It does not interact with us in any way other than providing the gravity, extra gravity. So we know that this extra matter is there, which creates extra mass in the universe, but we do not know what it is made of and how much this dark matter exists. As an estimate, 25% of the universe is made of this mysterious dark matter. So this is the first find that we had, and now the entire matter is something like 29%, out of which only 4% is the visible matter and 25% is dark matter. So it turns out that 5% is the thing that we can see and measure and experiment and keep record of, keep basically logs of these things that we examine. But 25% of the universe is something that we cannot even see. We are completely blind towards that kind of matter that exists in space, and therefore this particular finding was baffling the scientists. And that time we actually found out that the expansion was happening more rapidly than it should have been. That means there has to be some energy which is working against the dark matter, and this thing is much more powerful than the dark matter, and it is basically causing the expansion of this universe. So now we do not know what is dark matter, and we do not know what is this anti-dark matter energy which is acting against the dark matter. So dark matter basically pulls everything together and form the galaxies and stars, create extra gravity so that we can take shape, our atoms can combine together, etc. That is the property of dark matter. But the other force is negative. It is a negative expression of the energy which is present in the dark matter. So since we do not know what is this energy, some scientists say that it is a energy of the vacuum. But nevertheless, it is very difficult to explain this, and therefore, this if this energy has to exist, and in order to adhere to the law of conservation of energy, this energy must be negative energy. That means it is working against all other energies, and this energy is accelerating the expansion of the universe. Therefore, this energy has to be much more powerful than all other fundamental forces that we see in our universe all around us. So, fundamental forces are nuclear forces, gravity, electromagnetism, etc. These are the fundamental forces. So, dark energy, which we do not know what causes it, is a negative energy, and it is much more powerful than the energy that we experience in our universe. So these are the certain baffling truth about the dark energy. Something is causing this energy, and if you measure the energy complete weight of the universe, because we know that the energy is equal to mass because of this equation Einstein gave, E is equal to mc square. uh, the whole point is that the 75% or 70% of the space consists of this form of energy, which is negative energy, or some people also say 0 point energy. Even if it is not negative, the energy exerts 0 point pressure, and it acts against the energy or the gravity created by the dark matter. So in nutshell, dark energy is sort of an anti-gravity, which is taking the all objects in the universe and expanding them, also at the same time accelerating the expansion. So this is has been baffling the scientists for a very long time, and the nature of the dark energy is not very well understood. We do not know what causes it, whether it is a force which exists in our universe as a inherent quality, or it is a force which is coming from outside the space, outside the visible universe. There is some big object which is parked outside our visible universe, which causes this pull towards itself. Or is it another form of the gravity itself? That means there is a lot of dark matter which is now on the outskirts of the universe, pulling everything towards it. Whatever the cause may be, we have not found answers for both these puzzles that we have, which is dark matter as well as the dark energy. And our current model of physics also is not able to explain both of these existence of dark energy and dark matter, which is almost 96% of our space. So in nutshell, we think that we know everything, and we can see these large bodies, stars, black holes, etc. But the reality is that that is only 4%. 96% is something that we have no idea about, and that is why I feel that understanding dark energy is very important, because that will give us the true meaning of reality. Because whatever we see is only 4%. That may not be the entire reality of our universe or our existence. Understanding the dark matter, what is dark matter, and also subsequently understanding what is the dark energy which is acting against the dark matter and winning and increasing the speed of expansion of the universe. Now, how does this dark energy affect us? If the expansion becomes very high, right now we know that expansion is happening all over the place in the space, and we know we can measure the acceleration at which we are basically going away from each other. All the planets are going, all the galaxies are spreading out and moving away from each other. We already know that speed, it's pretty high, but certain portion of the space do not show that it is expanding as fast, but certain regions of the space show that they are expanding faster. So even though we know that this expansion is happening and it is accelerating, but it is not constant all over the place. So to find out a constant is also not possible. So it's very baffling. We cannot associate any property with the expansion of the universe which is caused by the dark energy. And therefore, it is something which, if it basically expand forever, eventually a time will come when the dark energy will become so powerful that it will rip the uh, nucleus of the atom, and the matter that we know today, uh, like protons and neutrons, which are found in the nucleus. The dark energy will be so strong, it will overcome the strong nuclear force and rip the atom, and that will be the end of the universe, because there will be no matter left, and there will be no stars, there will be no electrons, protons, etc. Everything will become will be ripped out by the dark energy. So I think these are certain hypotheses which we are grappling with, and more research is required. A lot of these are the a lot of surprising facts about our space, and it is very interesting to even think about it. Imagine 96% reality is something that we cannot even experience, and what we experience is only 4%. So I think it is very important to understand and distinguish between what we see, and if we consider that as real, that means we are going somewhere very wrong, because 96% of the reality of this space, we don't even know what it is. So friends, this is very baffling, and I thought I will talk about specifically dark energy, and inculcate those ideas into you. And if you have any thought process, any comments, do send in your chat messages, and I will respond to you. And for today, I'd like to say goodbye, only to catch you again next Monday in Multiverse with another interesting topic. Until then, I'd like to say goodbye for today. You have a good week ahead, and I'll catch you again.